Hello and welcome to today's session. What actually belongs in a vertical lift module and what doesn't, right? Real inventory comparisons against existing storage methods. My name is Michael Levins and I'm Group Editorial Director with Peerless Media Supply Chain Group, which of course includes Modern Materials Handling Magazine. And I'll be your moderator for today's discussion brought to you by our friends at Reb Storage Systems International. Now, today's warehouses and distribution centers are under constant pressure to do more with less, right? Less space, less labor, and less margin for inefficiency. At the same time, growing SKU counts and increasingly complex fulfillment requirements are forcing operations leaders to reevaluate how inventory is stored, accessed, and managed. Now, that raises an important question. Is a vertical lift module the right solution for your operation, or would another storage approach deliver greater value to your operation? Well, in today's session, we're going to tackle that question head on by examining real-world inventory profiles and storage scenarios to determine where VLMs can provide measurable gains in storage density, picking efficiency, and space utilization, and of course, where alternative storage systems may be a better fit. Now, to guide us through this discussion today, I'm pleased to welcome Stacy Stowell. And Stacy is Automation Sales and Business Development Manager with Reb Storage Systems International. Now, Stacy brings more than 20 years of experience in the materials handling and automation industry. She helps organizations improve operational performance through the strategic application of automation technologies. Now, her experience spans a very wide range of solutions in customer environments and giving her a unique perspective on where VLMs fit within today's evolving warehouse operations. Stacy, we are delighted to have you with us today. Now, before we turn the podium over to Stacy, I just want to let everybody know, and a quick reminder, that we're going to reserve some time at the end of the presentation for a live Q&A. So please submit your questions at any time during Stacy's presentation today. And we're going to get to as many as we can. Now, if we're unable to address your question during today's session, we're going to make sure that question is forwarded over to Stacy, and she'll be able to get back to you via email. So with that, Stacy, I'm going to hand the podium over to you. Take it away.
Thank you, Mike. So what we're going to be discussing today is we're kind of challenging the ideas of what actually belongs in a VLM. We're going to walk through a VLM overview. We're going to talk about some real inventory comparisons. We're going to talk about what types of inventory aren't so great for a VLM, and then I'm going to give you some contact information if you would like to get a hold of me and have a conversation about technical data. So, what is a vertical lift module? Before we look into specific applications, let's take a look at this. The vertical lift module is an automated goods-to-person storage and retrieval system that stores inventory on trays inside an enclosed structure and automatically delivers those trays when requested by an operator. The key difference between a VLM and traditional storage methods is that we are no longer asking an employee to travel to inventory. Instead, the inventory comes directly to them at an ergonomic pick station. This allows organizations to fully utilize their building height rather than consuming valuable floor space with racking and aisles. Key points to remember as we move through this presentation: the VLM achieves optimal density. Often when applying a VLM to existing goods, we reduce the floor space needed to store those goods by up to 90%. Increase productivity by eliminating wasted travel and motion. Increase pick speed. Trays return in as little as 15 seconds when using staging technology like the Ergotech by Vertimag. Average speed return tray using traditional VLM technology averages less than a minute. Laser pointers and LED indicators ensure accuracy and speed in locating items inside the tray. Versatility in tray configurations create solutions unique to your inventory challenges. And the VLM is safe and secure. To the safety, we have no floor lifts, no ladders, no reaching, no bending. Security can be assigned at the individual tray level to track or limit access to valuable tools or products. Now that we've identified what a VLM is, let's take a look at the fundamental trade-off that exists in most traditional storage. The storage method on the left is for fast or frequent picking. Items are highly visible and they're stored in categories in what is typically picked together. This reduces search time for operators. The drawback is it is a spread out way to use your inventory floor space. So it does take up quite a bit of floor space. On the right, the layout is optimized for density by storing inventories of similar heights together and tailoring each shelf size to accommodate those heights. We're using our space more effectively. However, as density increases, picking becomes slower because operators travel further and search more. So they're sacrificing time in order to achieve that density. Historically, warehouses have to choose between one of these two objectives. VLMs give us the opportunity to rethink traditional storage layouts. By using vertical space and automatically presenting inventory to operators, VLMs create a high density while simultaneously achieving a high pick volume. The result is more storage capacity, higher throughput, incredible inventory control while repurposing floor space for revenue generating activities. Let's take a closer look at the images that we've just visited in the next few slides as we present a user case. So the slides we have been looking at are in a maintenance crib. Maintenance crib has everything that you need to take care of your line and your facility. Fuses, motors, cleaning equipment, drives, conveyor belts, screws, nuts, anything that you're tooling, anything that you would typically see in a maintenance crib. This company's primary goal was to reclaim some floor space without reducing access to inventory. They wanted to support future growth and additional production activities within their existing maintenance building. The challenge was finding a better way to utilize the space so that the tooling could exist in the maintenance crib with the new objectives for that space. So our current storage method is shown in this slide, and the inventory is stored on traditional shelving that is reaching approximately 6 foot high. The racking was selected at that height by the customer to ensure operators could easily and safely reach all products while picking and ensure easy identification of components for rapid picking. As inventory requirements increased, the only practical way to add storage was to expand horizontally and by adding more shelving and aisles. This again consumed more floor space. What we notice here in the photo or in the image is that we do have about 20 feet of ceiling height and we are using roughly 6 feet of that. In other words, the facility has plenty of cubic volume available that is not fully utilized by traditional storage. Rather than continuing to extend the storage footprint, our solution was to convert the unused vertical space into productive storage capacity. This is a common and popular application for VLM. The company implemented 2 VLMs that extend nearly to the full height of the building. Instead of limiting storage to what employees can see and safely reach, the VLM stores inventory throughout the entire vertical warehouse and automatically retrieves the required tray on demand. Every item, regardless of where it is stored in the VLM, is delivered to the same ergonomic height, picking locations, and creating an unmatched user safety because we're eliminating those ladders, we're reducing reaching, bending, floor lifts. The picking process becomes safer and more consistent and up to 7 times faster than traditional racking and storage and retrieval. If we look closely at the original storage method, we can identify a second but less obvious challenge in the traditional inventory. Traditional shelving is typically installed with fixed shelf spacing because inventory comes in many different shapes and sizes. The shelf spacing is usually determined by the tallest items that need to fit in that section. As a result, many locations have significant airspace above the stored products. When compounded by thousands of SKUs, small pockets of air become a significantly large amount of wasted space. So not only is this facility underutilizing the building's height, but it's wasting storage volume on the shelving unit itself. Let's explore how dynamic tray spacing helps eliminate airspace between the product and the tray. VLM addresses wasted shelf or air space throughout the dynamic tray spacing. Instead of fixed shelf heights, inventory is grouped or stacked on trays with product of similar height. When the tray is returned to storage, the system automatically senses and measures the overall height and stores it in the next available location that can accommodate that height. As a result, there's typically less than an inch of clearance between trays. Compare this to traditional shelving, where several inches of unused space may exist above every product. Now that we have eliminated the wasted air space, let's explore reclaiming some space within the actual storage containers themselves. Traditional storage environments standardize on a limited number of bin sizes to simplify the purchasing and organization. This can lead to containers that are significantly larger than the product it holds. The result is unused storage volume within each bin. Again, when multiplied over the number of products stocked, the space saved becomes significant. This hidden inefficiency further reduces storage density and increases the amount of shelving needed to support inventory levels. VLMs do not rely on standard bins. Trays can be configured with dividers, partitions, compartments that closely match the product being stored. For small fasteners to large motors and tools, VLM trays can be configured to create dimensions that very closely match the product to be stored, thus eliminating airspace in a manner that traditional storage cannot achieve. Note that when storing a large number of SKUs in a single tray, we recommend the use of a laser pointer or an LED indicator to pull the operator's eyes directly to the component to be pulled. This adds accuracy and speed to the pick process. At this point, we've discussed three major sources of wasted space: unused building height, unused shelf space, and unused container space. The solution applied creates a dramatic reduction in the footprint required to store the same inventory. Now let's take a look at the total solution. The company's objective was simple: reclaim floor space so more operational activities can be performed in the existing facility. Let's measure the result based on the customer's challenge. The metric the customer identified for their motivation for exploring more effective storage was to reclaim floor space. Note, the company did not lose storage capacity. The company actually gained storage capacity through increased density within the VLM. An added benefit, when we integrated the VLM operating system to the SAP at the customer's facility, we created a previously unachievable real-time view into inventory. We measured the goal to reclaim square footage against the actual floor space recovered using the VLM solution. Floor space utilization went from 2,500 square feet to 288 square feet. That is an 88.5% decrease in space consumed. The real value isn't in the VLM itself, but what the VLM makes possible. By reducing storage footprint by nearly 90%, the company opened up operational space valued at a national average of $9 per square foot. The total is almost $230,000 annually. Also, that ROI on a VLM begins on day one. Through the example, we've established a simple logic that can be applied to VLM storage and retrieval applications. Usage of vertical space plus dynamic tray positioning plus intentional tray organization equals optimal density and increased pick speed. In our next example, the company had two areas they really wanted us to address. The first area was to create safe handling for some large steel drain grating. The second objective was to reclaim floor space and reduce pick times in areas where parts and components were stocked. While the maintenance crib focused primarily on maximizing storage density, this company creates a unique opportunity to apply VLM technology to a safe, ergonomic handling of materials in addition to the more typical application in the assembly and spares area. The steel grates are stored in multi-level cantilever racking. Well, this provided some vertical storage, accessing the material required employees to work together with forklifts and manually load and unload the heavy grates in elevated locations. Each level contains multiple grates. To achieve FIFO, the grates have to be pulled and restacked. The most concerning issue was the safe handling. The footed grates become nested in the open grid of the grate underneath, requiring hands to assist untangling them to get them loaded onto a forklift. The primary goal here is not storage, but a safe and more controlled process for handling this material. Our solution is to apply VLM. Each VLM tray is designed to hold 4 steel grates without stacking and eliminating the need to disentangle in order to access the grates. Human hands are no longer at risk. When the grate is required, the VLM delivers the tray at a consistent ergonomic access point. Rather than relying on forklifts and human hands, the retrieval of the material is facilitated by an overhead crane, enabling intentional placement of grates into the machine and a controlled lift out of the machine. The VLM transforms this dangerous forklift and human hand process into a controlled and intentional storage and retrieval process. This process addresses safety concerns while creating consistent ease of accessibility. Now let's explore the assembly and parts storage challenges for this company. This storage method gives the impression of density through uniformed appearance. Every storage location is occupied by a uniform tote that takes up almost the entire vertical space available. The shelf elevation and tote size are standardized rather than fitting the product to the product being stored. The first challenge that we see is the employees must use ride-on vertical mast lifts to access the parts stored on upper levels. While effective, the added travel time, the added equipment utilization, and the additional safety concerns are added to the pick process. On investigation, we locate a second challenge. We find that there are various levels of inventory in the totes. Some totes are actually empty. While racking and bin size present as dense, there's actually significant storage of air in this application. The totes are identical in this example with the exception of the labeling. This method relies on strict mapping protocol and barcoding to locate the product that's within the totes, as well as specialized equipment in the ride-on vertical masts. The storage method is the exact opposite of goods to person, in that the masts are literally delivering people vertically to the goods. Again, we're going to realize the benefit of dynamic tray positioning, which is well captured in this image provided. The tray heights are monitored within the machine, where the tray height is sensed and deposited into the first available space. Dynamic tray positioning uses minimal space between well-organized trays. Tight organization of the components creates density within the tray. Instead of forcing all the products into a standard uniform tote, the trays are tailored to inventory and minimize wasted space. When combined with optimizing the use of vertical space and dynamic tray positioning, well-organized trays create a dense storage system that is customized to the inventory while reclaiming significant space, travel, and employee time. There is a second location within this facility. Let's explore the small parts and components section. The area shows large quantity of small assembly components and well-organized tote systems. The method has done a better job at minimizing air storage, but presents another challenge. There are over 40 individual racks for small components. The challenge here is travel. To complete the pick, the operator must physically walk to the storage area, locate the correct tote, retrieve the required quantity, and deliver it to the point of use. While individual picks may take minimal time, multiply them and the travel and labor needed to complete a pick through thousands of SKUs per week. Significant labor is spent moving inventory either by retrieving or by storing that inventory. Our challenge here is to resolve the labor and productivity issues with this storage method. In the solution, the picker remains in one location. The VLM retrieves and presents the required tray. Combined with the rapid retrieval technology like the Vertimag Ergotech, you can realize an incredible value by eliminating miles of travel with as little as a 15-second transition between trays. By applying our previously established logic of using the available vertical space plus the dynamic tray positioning plus the well-organized tray, we are able to show optimal density and an incredible amount of value for this classic use case. Let's compare the value of the solution to our customer's goal. This solution really speaks for itself. We met our 3 objectives. We successfully achieved safe handling of the heavy drain grades. We reclaimed 90% of the floor space in the 2 classic use case for VLM. Because operators no longer travel through storage aisles or ride en masse to retrieve inventory, weekly picking labor is reduced from 160 man-hours to less than 40. That is a 75% reduction in pick labor. The combined result was a value of over $380,000 annually while creating a safer work environment and freeing space for operational growth. Our next user case explores safe handling to reduce the risk of injury to workers and to the product. In this manufacturing facility, unlike small parts or assembly components, these products are long and heavy and susceptible to damage during handling. The company's primary goal is to improve safety for the workers, with a secondary goal of eliminating product damage during storage and retrieval. We would like to not damage the humans or the steel while handling it. Direct quote. The current storage method is cantilever racks. Cantilever racks are commonly and successfully used for long materials. In this case, there are several challenges to the traditional storage method. First challenge, operators must manually retrieve tubes from racks, often handling material above waist height, requiring human coordination with fork truck or other equipment. In addition to the human safety concern, the storage method increases the potential of damage to the tube stock. The material is ordered with the correct finish that will be needed for the finished part after machining. Tubes can shift in this storage method. They can roll, they can drag against rack stops and causing damage to the material. The damage causes an additional process to work the metal to clean up the damage, or in some cases, and if it's gouged, to scrap the metal altogether. The VLM solution stores tube stock in dedicated tray locations designed specifically for the product. Examples provided in this image show tube stock is being supported and separated with custom storage cradles, preventing contact between products. Cradles can be simple to complex, but they are a great way to keep product isolated and spaced in a way that makes it easier to handle. Cradles resolve the objective to store the tube stock in a manner that preserves the quality of the material from the time it enters inventory to the time that it's needed in production. Now that each tube is intentionally supported and separated throughout the storage, eliminating roll, shift damage, or tube-to-tube contact damage, we use a jib crane to assist placing the tubes in a controlled manner, reducing the risk of drag damage on the load and unload. This application demonstrates the value of a VLM extends beyond storage and density and pick productivity. The company objectives here were to improve safe handling and eliminate product damage by combining the automated retrieval, ergonomic presentation, custom wood cradles, and a jib crane. We have created a solution that reduces risk of injury and product damage. The result is a safer process to both human and product and maintains an immediate access to material. The greatest value here is not measured in square footage, but in injuries avoided and material protected. Our next user case comes from metal fabrication and is another case where we are placing a VLM in a non-traditional environment. Our previous examples show VLM optimizing space utilization in the maintenance crib, labor productivity in assembly and parts, safe handling with the steel drain grids, and safe product protection with the tube stock. Our final example of what belongs in a VLM will kind of focus on the security that a VLM can provide. The challenge this customer puts before us is not one of storage capacity, but one of tooling visibility and accountability. The process to pick tooling for any given component was left largely to the operator to remember what needed to be picked. While work instructions did exist, they were often out of date and hand-noted in some cases. This caused tool mispicks, this caused hoarding at workstation, and this caused operator dissatisfaction. Operators spent significant time searching for tooling, which delayed setups and changeovers, causing negative impact on production scheduling. It also created a frustration among operators and a lack of confidence in their process. The VLM solution reorganized the tooling around the manufacture process. Each tray in the VLM is specific to a fabricated product and assigned a security level that limits access to the operator responsible for that fabricated product's production run. When a job is released, the operator pulls the entire tray specific to that job and takes the tray to the machine to be changed over. The tray is released only to employees with authorization to pull that tray. The VLM tracks the tray, the tooling, and the user until the tooling is returned to the VLM. This establishes clear visibility on tool location. The security parameters assigned to these trays result in excellent visibility of the actual location of the tooling. The process has also eliminated tribal knowledge on tooling needed for each setup and has significantly reduced time for changeover between products. We were also able to designate certain tools to certain materials using this method. The previous method had a danger of carbon transfer between tooling that was previously available to pull for either industrial metalworking applications as well as kitchen equipment. The result is the operators know where the tool is located to complete tool packages on demand. Setup activities are streamlined and delays are largely eliminated. Operators are confident when they pull the exact tooling they need for every changeover, eliminating frustration. The VLM transferred tooling management from a storage function into a controlled production support process. Tooling is organized by job, tracked, and immediately accessible. While we were not challenged to reclaim space, the nature of the VLM eliminated all other storage methods in the tool room, opening it up for revenue-generating activities. Now that we have taken a look at some traditional and some non-traditional uses for what goes into a VLM, let's take a quick look at things that aren't necessarily ideal for VLM storage. Liquids stored in large containers have an unreliable weight distribution as the liquid can shift while the tray is moving. This has the potential to destabilize the tray during transit, causing the VLM to stop and report an error. If liquids were to spill, we risk damaging sensors and other electronic components, again, causing the VLM to stop and report error. The simple solution is to go with static racking. Maybe selective racking is the better solution for this. Items that can move around. Round or irregular shape items that can move, bounce, fall during tray storage and retrieval are not ideal for a VLM. The shifting and moving or falling can trigger sensors, causing the VLM to stop and report an error. While it's true, VLMs can handle a significant amount of weight, note that we've shown you examples today that can handle over 1 ton of metal. There are better ways to store products that exceed the tray capacity for a VLM. The containers in this image are nearly 4,000 pounds and are probably better served by selective or cantilever racking. Items that are dirty or create debris. The example here shows floral arrangements that will eventually make their way to box stores and grocery stores. They are shipped in open packaging. Falling debris, dirt, oils can block sensors on the VLM. The better solution in this case is probably any pallet racking. For florals, pallet flow racking was selected as the floral product is highly perishable, and they really needed a FIFO system. Bulk inventory and high throughput. Skids of bulk inventory goods are not ideal for VLM. First, VLM is not intended for tall stacks. And depending on the vendor of the VLM, the depth between the tray heights may be only 24 inches, eliminating VLM from consideration on bulk items. A better alternative might be drive-in or drive-through racking, pellet flow, or pellet runner racking. In this example, we have a high SKU count being stored together. The containers hold cheese, and they all have the same expiration date. While the VLM software can help you track perishable inventory, it's not effective for staging pallets for distribution. A better alternative in this scenario is going to be pushback racking. In this example, we have products that should not touch each other. We need to protect and preserve the finish. The product is tall and awkward to store. The size, shape, and stability of this item makes it a better candidate for pallet racking with custom designed pallets to limit the product's ability to damage itself during transit or storage. Extreme temperatures. As a general rule, the materials used in a VLM do not respond well to extreme temperatures. The example given is for vaccines, and we were able to accommodate the storage requirements using pallet flow rack for the FIFO system. That is the end of my presentation. I am so grateful to have spent time with you today. We have multiple different applications from VLM, but there's so much more to explore. Call me to explore storage of luxury items, jewelry, leather, apparel. VLM creates a safe and clean storage environment. If you have efficiency challenges in your production, let's discuss how VLM may contribute to a leaner storage and operation. Want to explore how VLM can help you in the pharmaceutical industry, backroom retail? It's very versatile. With the available loads of 2,200 pounds per tray, we can accommodate a large number of tray arrangements creatively, and we have a lot of capacity to resolve your storage challenges with creative solutions. I look forward to connecting with you soon. Thank you for your time. Mike, back to you.
Terrific job, Stacy. Thank you so much. Excellent job today. Now, we have a number of questions rolling in for you. And I'm going to remind everybody, too, at this moment, please continue to submit those questions. If we don't have a chance to get to your question today, we are going to package those up and move them over to Stacy, and she'll be able to get back to you directly via email. So, Stacy, we do have time for a few questions that have rolled in. So the first question, Stacy, does the VLM supplier supply the dividers, bins, or whatever else is holding the products on the VLM tray? Is that coming from the supplier?
Mike, that's such a good question. While the VLM vendor can typically take care of dividers, they typically supply dividers. We would suggest you go to a solution provider like Reb Storage Systems. They can really customize those trays with bins, custom dividers, custom solutions that really give you a really custom solution to your unique inventory challenges.
Right. So when you say custom divider, that could be like the steel rod holder that you showed. The VLM provider can do that as well, correct? Like super custom.
Yes. Anyone like Reb Storage Systems who provide solutions as opposed to just a product. We're not necessarily a product vendor, but a solution provider.
Right.
Yeah, we could help you customize those bins.
Excellent. A couple more questions that have rolled in here, Stacy. If the products on the VLM are heavy to where they need to use an overhead crane, do you typically go through the VLM provider for that as well?
Well, again, it's the same answer. So Reb is a storage solution provider. So we provide the entire solution. So we can provide the overhead crane with the VLM. It actually comes from two different vendors. But when you're working with a systems integrator and a solution provider, we can typically take care of the whole thing for you.
Gotcha. So one-stop shop, really. And that was a few questions around that. Yeah, that's terrific. And just one more question. We are kind of up against the clock, Stacy, but I like this question, and a few people have asked this. And obviously, we've had some attendees here who are very interested in taking, sort of that first step. So what is the first thing you would tell a prospective user who's trying to determine if a VLM is really the right fit for their operations? What's that first thing you'd tell them?
So I am going to answer that question in two parts. The first part is the answer can be applied to so many things as we're working through our daily challenges. Be curious and make
Mm-hmm.
no assumptions.
Right.
I've shown you some non-traditional usage of VLM today. I've shown
Yeah.
you some things that you were probably surprised can go into a VLM today.
Yeah.
I've
Absolutely.
talked about 2,200 pounds of tray storage capacity. So
Mm-hmm.
don't make any assumptions about what a VLM can store. There are a lot of creative ways that we can help you address your inventory challenges with VLM or with other racking. So first is make no assumptions and be curious. The
Yeah.
second way that I'm going to address that is, visit our website on Reb Storage and take a look at the QR codes around the VLMs themselves. They will take you to some information that you can start gathering on your own on your facility and your environment that helps kind of lead you to the right questions to ask about, are we ready for a VLM?
Sure, absolutely. That's great advice. Well, we are up against the clock. Stacy Stillwell, Automation Sales and Business Development Manager with Reb Storage Systems International. Terrific job today. Thank you so much, Stacy. We really appreciate it.
Thank you, Michael.
And we want to thank Reb Storage Systems International again for sponsoring today's terrific session. I want to thank everybody as well for attending. Have a great day.